Are you paying
Cool,
attention at
yeah.
all to Three Eye Atlas? Are you
Oh, there's
watching
the comet?
Yeah, whatever it is.
Yeah. I mean, one thing I can say is, like, look, if I was aware of any evidence of aliens.
What is happening right now behind our sun that scientists can't see, and why could it change everything we know about the universe? The mysterious interstellar object known as Three Eye Atlas has vanished from view, entering a hidden phase just 72 hours before reaching its closest point to the sun. From impossible chemistry to a trajectory that seems engineered, every anomaly challenges the laws of physics themselves. Stay with us, because what Three Eye Atlas might reveal when it re-emerges could rewrite the very foundation of science. For centuries, humans have looked toward the sun for warmth and guidance, never imagining that one day it would also become the curtain hiding something extraordinary. In late October, astronomers realized that Atlas, an interstellar visitor millions of years in the making, had vanished completely from view. As it slipped behind the sun in perfect alignment, every telescope, satellite, and deep space observatory fell silent. The world's most advanced eyes in space were suddenly blind. Across the scientific community, tension spread quietly. Observatories from Chile to Hawaii logged their final readings as Atlas disappeared into solar conjunction. Behind that blinding wall of light, the object was bombarded by more than 33 gigawatts of solar radiation, an energy burst strong enough to melt any ordinary comet to vapor. Yet this one somehow survived. What kind of material could endure such fury without disintegrating? Meanwhile, analysts at Harvard and the European Space Agency compared notes. Atlas's timing wasn't just remarkable, it was unnerving. Its perihelion, the point of closest approach to the sun, occurred during the exact 72-hour period when no human instrument could see it. The odds of that coincidence were astronomically low. Was it fate, physics, or something deliberately calculated? To make things stranger, fragments of radio interference began appearing on frequencies used for solar monitoring. At first, technicians dismissed them as static, but their pattern, rhythmic and symmetrical, didn't behave like solar noise. Some wondered if it was simply electromagnetic chaos, while others dared to ask a darker question. Was Atlas emitting something of its own? In mission control rooms across the world, scientists waited for the blackout to end. Would the object reappear in its predicted orbit, or would something have changed? When the light returned, would they still be observing a comet, or would they be confronting a technology no one had language for? Could something beyond our understanding be using the sun itself as cover? Stay with us as the mystery deepens. The Cosmic Blueprint. When Atlas finally emerged from behind the sun, what astronomers saw didn't match their calculations. Its brightness, rotation, and tail had shifted in ways that no natural comet should. The first post-blackout data streamed in from Chile's Very Large Telescope, and what it revealed left even veteran researchers unsettled. Atlas wasn't behaving like a drifting relic of frozen gas. It was acting as though it were following instructions. Spectroscopic readings brought the first shock. A concentrated emission of nickel, unlike anything in known comets, was detected. The pattern of its distribution, clustered in a 600-kilometer core zone, suggested structure, not chaos. On Earth, the only place such ratios appear is inside engineered alloys created through the carbonyl process. That was no random formation. It implied precision at a molecular level, as though Atlas had been assembled rather than born. Meanwhile, cyanide gases streamed from an entirely different region, 840 kilometers wide and chemically detached from the nickel core. Normally, sublimating compounds disperse uniformly, dictated by solar heating. Atlas ignored that rule completely. The only logical conclusion: two distinct materials were releasing energy independently. To a few daring voices, it looked like a form of compartmentalization, function-specific regions within a single structure. The geometry of its orbit added yet another riddle. Moving within only 5 degrees of the ecliptic plane, the same narrow disk where all planets orbit, the object's trajectory seemed designed for maximum efficiency. That path offered sequential proximity to Mars, Venus, and Earth, like a carefully plotted tour of our solar system. For a natural interstellar wanderer, the probability of such alignment was 0.2%. For an engineered traveler, it would be optimal. Even its light behaved strangely. Polarization data from the Keck Observatory recorded a negative value unprecedented in any known comet, suggesting an exterior unlike dust or ice, reflective, organized, perhaps even metallic. As more readings came in, one conclusion began to spread through the private messages of a few astronomers. If this was a coincidence, it was the most complex one the cosmos had ever produced. Was it possible that something crafted with such precision emerged from nature itself, or was it echoing a design far older than human memory dares to recall? Walk with us into the hidden corners of the story. The quiet activation. In the days following the nickel and cyanide revelations, a strange stillness swept across the astronomical community. Officially, there was no emergency. Unofficially, private channels lit up between defense agencies and observatories. Something in the new data had triggered a protocol not seen since the age of nuclear near misses. The target wasn't a missile, it was 3I Atlas. While the public waited for open analysis, the International Asteroid Warning Network quietly shifted into high alert. Normally, this coalition only mobilized for impact threats capable of ending civilization. Yet 3I Atlas was on a trajectory far from Earth, more distant than Mars at its nearest pass. Still, resource allocations were suddenly restructured, monitoring intensified, and encrypted transmissions began circulating under planetary defense classification. In Washington and Geneva, meetings extended past midnight. Internal documents confirmed what few dared to say aloud. The object's coordinated anomalies, its orbit, chemistry, and scale made it statistically indistinguishable from an artificial construct. For the first time in recorded history, a non-threatening celestial body was treated as a possible technological artifact. Within hours, observation time on major telescopes was seized by national directives. At the same time, NASA's high-resolution images from the Mars Reconnaissance Orbiter, taken when 3I Atlas passed near the red planet weeks earlier, vanished from public databases. Requests for access were deferred indefinitely, citing review in progress. Harvard's Avi Loeb, already vocal about the object's engineered signatures, sent direct inquiries that received no response. The silence grew as the blackout of information deepened. Meanwhile, across the Atlantic, the European Space Agency took a different route. Their ExoMars Trace Gas Orbiter released neutral imagery showing a faint, diffuse body resembling a comet. Yet buried within their dataset was a spectroscopic profile that contradicted that calm picture. A composition far too complex for ordinary ice and rock. Researchers who noticed it were quietly advised not to draw conclusions until post-perihelion verification. By late October, the question was no longer whether 3I Atlas was natural or artificial, it was whether governments were preparing for something beyond science. Inside locked observatories and sealed conference rooms, whispers began to merge into a single uneasy thought. Maybe humanity wasn't alone in observing. What were they bracing for that the world wasn't meant to see? Let us guide you into what no one expected. The collision of minds. As governments tightened their silence, the debate within science turned volatile. What had begun as quiet speculation now fractured the global research community. In university halls and online forums, a single question divided experts. Could 3I Atlas truly be something designed? Each new piece of data deepened the split between those demanding conventional explanations and those who believed the evidence pointed to something extraordinary. Avi Loeb, the Harvard astrophysicist who first warned that the object's behavior defied natural classification, became a lightning rod. In a series of public posts, he urged transparency, arguing that dismissing anomalies because they felt uncomfortable was no longer science. His critics, including prominent planetary astronomers, accused him of sensationalism. They claimed that telescope tracking errors, not exotic physics, were behind the illusion of precision. The debate was no longer academic, it was ideological. Meanwhile, smaller research teams quietly compared the official statements with raw observational data. Several noticed discrepancies between what space agencies reported and what their instruments actually recorded. Minor velocity shifts, inconsistent brightness curves, and non-random changes in trajectory suggested that 3I Atlas was subtly altering its motion. No one could explain how, and yet the numbers refused to conform to celestial mechanics alone. Inside observatories, unease replaced excitement. Younger scientists, still unbound by institutional caution, began to ask the questions others avoided. What if the object was not only visiting, but observing? If its orbit truly allowed multiple planetary flybys, could it be studying gravitational fields, magnetospheres, or perhaps life itself? These possibilities were whispered, not published, but they hung in the air heavier than any theory. As the arguments raged, data continued to flow in from probes and telescopes. Each new reading hinted that 3I Atlas might not be entirely passive. Some instruments detected faint emissions inconsistent with known cometary gases. Others observed slight variations in reflectivity, as though sections of the surface were shifting. The most unnerving realization was that these changes often corresponded with periods when humanity's attention was most fixed upon it. Science was supposed to seek truth through reason, yet now reason itself was at war. The universe had presented a puzzle too perfect to dismiss, and humanity's understanding of its place in space began to fracture under the weight of its own curiosity. Was 3I Atlas a mirror reflecting our doubts, or the messenger that would finally answer them? Stay here as the next twist unfolds. When 3I Atlas faces the fire. The moment the world had been waiting for arrived in silence. On October 29th, 3I Atlas reached perihelion, the closest point to the Sun in its million-year journey through interstellar space. Every instrument capable of observation was pointed toward the region of the sky where it should have been, but for 72 hours, no signal returned. The blackout wasn't just optical. Even the radio spectrum fell quiet. It was as if the object had slipped behind an invisible veil. When data finally began to flow again, the first frames were confusing. 3I Atlas had survived, but not unchanged. Its brightness was altered, its spectrum shifted, and subtle irregularities appeared in its orbital path. Analysts compared these measurements to pre-perihelion models and found discrepancies no natural process could fully explain. The object seemed to have lost velocity, just enough to remain gravitationally bound to the solar system. That single deviation defied the expected physics of a simple comet and opened the possibility of deliberate adjustment. At the European Space Agency's Control Center, a team examining data from the JUICE probe made a startling discovery. As the spacecraft passed within 64 million kilometers of the object, its instruments detected minute fluctuations in the surrounding magnetic field. These were not random solar interferences, but patterned oscillations, pulsing with mathematical precision. Some dismissed them as electronic noise. Others saw a signal encoded in magnetism itself. By the time ground observatories regained visual contact, 3I Atlas had developed faint, separate fragments trailing in its wake. They were small but structured, maintaining steady spacing and direction. Simulations suggested that they could be naturally ejected debris, yet the regularity of their motion hinted at control. The prospect that the main body had released components, perhaps probes or self-organizing structures, was debated behind closed doors. NASA's delayed publication of its high-resolution images only fueled speculation. When the photos finally appeared weeks later, they showed a surface unlike any comet previously documented. Instead of irregular terrain, there were regions of geometric consistency, parallel ridges, hexagonal voids, and smooth reflective zones that absorbed heat unevenly. Independent researchers proposed that these features might be mineral crystallization, but the precision of their symmetry was difficult to dismiss as coincidence. By December, as 3I Atlas moved away from the Sun, attention turned to its next milestones. It would pass near Earth's orbit, then approach Jupiter by March of the following year. Each encounter offered a new chance to test whether its altered trajectory remained stable or shifted again. The James Webb Space Telescope prepared to analyze its thermal emissions, hoping to detect whether the internal temperature behaved like a natural cooling body or maintained consistent regulation, as if energy were being managed from within. Public interest exploded. To many, 3I Atlas became more than a comet. It was a mirror reflecting humanity's limits. Was it an exotic fragment from a stellar nursery, or a silent creation crossing the light years with intent? As Jupiter's orbit drew near, NASA's Juno spacecraft prepared for one final encounter. If 3I Atlas had released smaller bodies, some might enter Jupiter's magnetic field, revealing faint clues about their composition. What began as curiosity had become the most profound investigation in modern science. When the final transmissions arrived, one truth was undeniable. Whatever 3I Atlas was, it had already changed how humanity saw itself. It blurred the line between discovery and contact. In its silent passage through our solar system, it left no message, only evidence that the universe still holds questions powerful enough to rewrite what we know. Were you stunned by the mystery of 3I Atlas and what it might mean for science? Tell us, do you think it's a natural phenomenon or something far more extraordinary?